Hi guys, good afternoon everyone. Good afternoon guys, how are you all? I hope everyone is doing well. So today we are going to talk about one of the really important topic of solutions chapter. So that is nothing but colligative properties, and this topic you can expect surely one question in your exam. So yes, we are going to talk about it. So before starting with the colligative properties, I know all of you, those who are new on the platform. Hi Akshay, good afternoon Akshay, how are you? So I know all those who are new on the platform, they want to know about me. So yes, let me just quickly introduce myself. So guys, I'm Manisha Rani. I have experience of online and offline teaching at Reputed Institute for more than 5 years. I have done masters from NIT Warakal and bachelor's from Delhi University in chemistry. And yes, I have cracked many of the prestigious exams like IIT JAM, CSIR, NET, and GATE. And yes, I have given best ranks through my students. So this was all about me, your chemistry educator at Unacademy. So yes, let's just quickly start with the topic without wasting the time. That is nothing but colligative properties. So what do you mean by, you're studying this chapter for the first time, Akshay? Okay. So Akshay, this is a topic of chapter solution of class 12th. Okay, so we are going to discuss about specifically a small topic today, which is colligative properties. You will be able to understand what is colligative properties. Okay, but if you get any doubt, you can let me know that ma'am, I'm not able to understand this term or that term, so I'll be explaining that, so no need to worry. Okay, so what do you mean by colligative properties? First of all, so the colligative properties are nothing but the properties. So obviously there are some properties, right? But which properties? So the properties which depends on the number, the properties which depends on the number of solute particles, to the total number, of particles present in solution. So mainly what I can relate here, that colligative properties are those properties which depends upon the number of solute particles to the total number of particles, means out of the total number of particles how much solute particles are present, right? So basically we can relate it as concentration. So basically we can relate all those properties which are going to depend upon this factor, they are considered as colligative properties. So we can relate that, and also they doesn't depend upon nature of it, like it doesn't depend what solute it is, what substance it is, what solvent you are taking. Very good, absolutely. So what we can relate, we can talk about present in a solution and not on the nature of it is called, very good Akshay, and not on the nature of it is called, is known as colligative properties. So there are 4 colligative properties which are very famously known to us. And what are those? Let's just quickly name them. So I hope everyone understood what are colligative properties, which depends upon number of solute particles to the total number of particles and not on the nature of it. It's called colligative properties. We have 4 of them. First one is relative lowering of vapor pressure, which in short form we also call it as RLVP. Relative lowering of vapor pressure. Then you have is second one is depression in freezing point, elevation in boiling point. Very good. Depression in freezing point, elevation in boiling point. Elevation in boiling point. And the fourth one, last but not the least, is osmotic pressure. Is the osmotic pressure. Very good. So basically these are the 4 properties which we have to learn. Okay, vapor pressure, like which shows relative lowering, depression in freezing point, elevation in boiling point, and osmotic pressure. So these are the 4 colligative properties which we are going to learn about. So in today's session, because it's a half an hour session, small session, we'll quickly try to complete the first 2 colligative properties, and next 2 colligative properties we'll be learning in the next session. So let's just start with the first. Yes, let's just start with the first colligative property only, which is nothing but relative lowering of vapor pressure. Very good, Akshay. Very good, everyone. Yes, relative lowering of vapor pressure. So what you can relate, guys, first of all, if we talk about Raoult's law, what Raoult's law said that the partial pressure of any substance is directly proportional to its mole fraction, and when we remove that proportionality sign, we used to get the P0A, which is nothing but the vapor pressure of pure solvent. So this is the equation which we know. It comes from what? It comes from the, yes, it comes from the Raoult's law, like whatever the components we can talk about. But when we'll be discussing about the colligative properties, guys, I want to tell you one very important thing before learning about this formula, that whatever colligative property you are going to talk about, whether relative lowering of vapor pressure, whether osmotic depression in freezing point, elevation in boiling point, the common statement which you are going to use, by which you are going to observe these properties, is what? That when a non-volatile solute is added to a volatile solvent. So in all these properties, how we have observed? We have observed when a non-volatile solute is added to a volatile solvent. What do you mean by non-volatile? The substance which cannot easily evaporate. So when a non-volatile solute is added to a volatile solvent. So this is a common statement you will be always using. And what I'm considering, obviously we have to give some denotion to it. So solute I consider as B and solvent I consider as A. So whenever you will be adding a non-volatile solute to a volatile solvent, so you have solvent as A, in that you have added volatile, non-volatile solute. So what you will observe, that's what we are going to, yes, very good, Akshay. So what is going to happen, that's what we are going to talk about. So whenever you do, right, this thing, like I can explain here, we have 4 colligative properties. So for the first 3 properties, you will mention like that only. When a non-volatile solute is added to a volatile solvent, its vapor pressure decreases, because relative lowering means, yes, that it is decreasing. Depression in freezing point means, again you will write a same statement. When a non-volatile solute is added to a volatile solvent, its freezing point decreases. But in the same condition, when you add a non-volatile solute to a volatile solvent, what happens? Boiling point increases. So this is common statement, common thing which we are going to do in every colligative property study, for the every colligative property study, that we are adding a non-volatile solute to a volatile solvent. So what will happen to a relative lowering of vapor pressure? So we can relate that PA, we can write according to the Raoult's law, P0A XA, according to Raoult's law. We can express that. But guys, PB, the vapor pressure due to solute will be 0, no? Because it's non-volatile. Tell me yes or no. Whether it is going to, yes, involve, or whether it is going to contribute towards the vapor pressure. No, because solute is non-volatile. As solute is non-volatile, so PB will be equal to 0. We can relate that, very simple. And for solvent, we can write according to Raoult's law this expression. What is PA, P0A, XA? I can mention here. You can relate that. PA is the partial pressure of solvent. Means how partial vapor pressure of solvent, which is given by, right? What will be P0A? It's a partial vapor pressure of pure solvent. Like when you are not taking in the mixture, just taking the solvent and then you are checking. PA is when you have taken in mixture, then what it is, that we are talking about. Plus you will be having, like, XA is the mole fraction of A component, which is solvent. Correct? I hope everyone is able to relate. XA is the mole fraction of solvent. Very good. Now what I can relate, can I do some changes, that PA is equal to P0A XA? Can I write, we know that the mole fraction of any two substance sum is equal to 1. So PA is equal to P0A. So instead of XA, can I write 1 minus xp, it's very simple guys. Yes, so I can write 1 minus xp. Very good. Basically from all these colligative properties, if I'll give you the idea guys, we are going to find out that how we can find it out the mole fraction of a solute, right? How we can find it out the concentration of solute or molar mass of solute basically. Okay, so that's what we can relate. So sum of mole fraction is 1. So what we can write, we can just rearrange this equation. So I can write P naught A minus P naught A x B. Okay, and if I'll just take this P naught A x B this side, I can write P naught A, this PA I will take this side on the right hand side, so it will be PA, and XB will be nothing but it will become P naught A minus PA divided by PB, like sorry, P naught A. So this is the expression that we get for the relative lowering of vapor pressure. What you can get mole fraction of solute by the formula P naught A minus PA, it's not plus, minus PA. So it's the pure solvent vapor pressure minus the partial pressure in the solution, how much it is achieving, what is the difference, divided by, you have again P naught A. That way you can find it out the mole fraction of solute, and that we can get in relative lowering of vapor pressure. What are the terms here? I can again mention P naught A is equal to vapor pressure of pure component, which is solvent we are taking. PA will be the partial vapor pressure of solvent. Solvent, right? Then next, in solution we can talk about. And what will be XB? Mole fraction of, correct Akshay? Yes everyone, mole fraction of solute. Very good. Now tell me guys, if you want to calculate the total pressure, suppose you wanted to do that, total vapor pressure of the solution, PS is the total vapor pressure of solution. Vapor pressure of solution. What is vapor pressure? It's very simple, the pressure exerted by the vapors of liquid. I can say that whatever is the partial pressure of A and B in the solution, that will give me the total vapor pressure. But I know PB, right? PB is equal to 0, so it means PS is equal to PA. Why? Means total vapor pressure of solution is equal to vapor pressure of the, yes, partial vapor pressure of the solvent. Why? Because PB is equal to 0 as it is a non-volatile. Okay, so in the formula you can write PA also and you can use PS also. Means if suppose they have given partial pressure of solvent in the question, you can utilize that. Or you can use the solution vapor pressure if they have given, that also you can utilize in the formula to calculate the mole fraction of solute, and it's very simple. I hope everyone is able to relate with it. Yes, it's clear. So let's just discuss one more colligative property as well, which is depression in freezing point. And after that only what we'll be doing? Yes, we'll be learning about few questions related to it. Okay, so let's just discuss about it and let's see who and all will be able to relate. But I hope everyone have understood about the relative lowering of vapor pressure. Yes, anyone is having any doubt? You can tell. So let's just discuss the second colligative property. Yes, exactly. PA is volatile because solvent is volatile. No, that's what we are taking a common condition. When a non-volatile solute is added to a volatile solvent. So it's volatile. Obviously, we'll be considering its pressure. Correct, Akshay? Very good. So let's just talk about the second one, which is nothing but what? The depression in freezing point. So in relative lowering of vapor pressure, what we have done, we have tried to find out how we can find it out the mole fraction of solute. From that basically we can get the molar mass of solute. By from all the colligative properties, one thing common which you can find it out, and that's why colligative properties are used also to calculate this particular quantity, is nothing but the molecular mass of solute. So depression in freezing point, what is it? So common statement everyone know, when a non-volatile solute is added to a volatile solvent. So what you're doing, common statement you have to write, non-volatile solute is added to a volatile solvent. Correct. Then what is observed is depression in freezing point. Freezing point is seen to be decreasing. Okay, that's what we can relate. So in that case, what we got to know, that change in the freezing point, because we are saying depression in freezing point. Freezing point has to decrease. Whatever was before of the solvent, once you added the non-volatile solute in it, its freezing point has decreased. Like the way it happened in the vapor pressure also. The moment you added to a solvent, suppose solvent was having before vapor pressure more, but the moment you added non-volatile solute, it is going to relatively lower down the vapor pressure. Okay, same way here, the freezing point is going to get lower down. So how we can relate? Obviously we have to find it out, the change in temperature. So the depression in freezing point we denoted with as delta TF, and what we found is that delta TF is directly proportional to molality. What is delta TF? Delta TF is nothing but change in freezing point, or we can relate that how much you will get depression in freezing point. And here M is nothing but, guys, molality. Remember, it is molality, the small m value that we find it out. Okay, now what we can relate, that whenever you have any proportionality sign, so you cannot solve any questions, any numericals related to it, so you have to introduce a constant. So you will be introducing a constant over here for removing the proportionality sign. So you will get Kf. What is Kf, guys? What is the name for it? It is called as molar depression constant. Depression constant, or it is also called as cryoscopic constant. So both are the names for it only. Kf is a molar depression constant, or it is also called as cryoscopic constant. How you find it out? Delta TF, guys. So delta TF is initial minus final, no? So you can relate that delta TF is TF naught minus TF. TF naught we consider is for solvent, freezing point, and TF is after adding solute. You are not having only solute or solvent, you are having solution. So solvent freezing point minus solution you will get the change in the freezing point, and that's how we can calculate. So delta TF is TF naught minus TF. TF naught is nothing but freezing point of solvent, and solution freezing point. Okay, Kf that we introduced over here is a molar depression constant or cryoscopic constant. How you find it out? So Kf value is found experimentally. How? Kf value is found experimentally, is calculated experimentally, and for different reaction, for different type of process, it is going to be different. So Kf value is calculated experimentally by using a formula of that value which we get. So how you find it out? Kf is equal to R into MA into TF naught square divided by 1000 into delta heat of, like, enthalpy of fusion. So basically enthalpy of fusion you will find it out experimentally. Then R is nothing but is universal gas constant. You can find it out that, like, you know that, right? Universal gas constant. So if you're talking in terms of energy, it will be either like 8.314 joule per Kelvin per mole, or if you're talking in terms of pressure, it will be 0.082 atm, right, liter per Kelvin per, right, atm liter per Kelvin per mole, like that, or it can be 0.083 bar, right? What we can relate? Liter per Kelvin per moles, like that you can relate. So any value you can utilize depending upon that. Now what is TF naught? TF naught is very simple. It is the freezing point of solvent. Correct, Akshay? Everyone? It's a freezing point of solvent. And yes, what is delta H? Fusion. It is enthalpy of fusion. So you can find out by this manner. Okay. Very good. So we have got to know how we get this Kf. What is M, guys? M is molality. How you define it? Let's just see that. So you know that delta Tf is equal to Kf dot M. Now what is M? M is molality. Molality, how it is defined as? So molality is nothing but the number of moles of solute dissolved in 1 kg of solvent. So this is the difference between molarity and molality. Remember, we take molality over here. What is that? Number of moles of solute dissolved in 1 kg of solvent. Dissolved in 1 kg of solvent. Okay, how we can just split it up, number of moles, how I can calculate WB by MB, given mass into molar mass, into 1000 divided by mass of solvent in grams. We can get that. So this is the molality. Can I use this equation 2 in 1, which is molality, right? Just elaborated form. So equation 2 in 1, what will get the formula? Very simple. I will get delta TF is equal to KF dot WB by MB into 1000 divided by mass of solvent in gram. So this is the formula for depression in freezing point. I hope everyone is able to relate. It's very simple. Okay, so we have learned about 2 colligative properties today, related lowering of vapor pressure and yes, elevation, not elevation, depression in freezing point. Talking about elevation in boiling point and the osmotic pressure, their graphs, everything we'll be discussing in next session. But today first, let's just discuss 1 to numericals related to, yes, to these 2 colligative properties. So let's just discuss first one of the colligative property relation, and let's see who and all will be able to answer it. So one of the question which I'm giving to all of you, yes, that is nothing but question is very important question asked in CBSE, ISE, in competitive exams, also NEET exams. So the question is 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate A, the freezing point depression. A, the freezing point depression. Freezing point depression. B, what? The freezing point of solution. Okay, so this is what you have to do. Now let's just see who and all will be able to get the answer. So I'm telling the freezing point depression option. So you have delta TF and yes, the freezing point of solution. So what we have given for the solution, we have given just TF. So we have to find it out, delta TF and TF. So let's see who and all will be giving the correct answer for it. The options that I'm giving is delta TF is 2.2 Kelvin and here 270.95 Kelvin is the TF. For the solution B is 1.12 Kelvin and here 292.75 Kelvin. C is 4.73 Kelvin and 192.8 Kelvin. Okay, and next what you can relate is yes, which is given. Okay, let me just give that. D is 1.79 and 312.14 Kelvin. So everyone, let's just see who and all will be able to give the correct answer. Yes. So first of all, what is the formula of ethylene glycol? So ethylene glycol is to the ethane molecule when you attach 2 OH. So it is like ethane 1,2-diol. That is your this thing, ethane 1,2-diol, C2H6OH. Now KF, all of you will be getting confused. So the KF for this reaction, it is not given here. I am giving you the value 1.86. It will be given in the question. KF is equal to 1.86. Everyone, yes. Let's just see who will be giving the correct answer in the chat. Okay, let's just discuss about it together. Okay, So 45 gram of ethylene glycol. So this is given to me is WB. I can find it out the MB of it by it. It's mixed with 600 gram of water. So they have given the MA. The mass of the solvent, like the MA is water is given, so I can find it out, and the mass of solvent is given, so I can relate that. That is WA I can consider. MA I can find it out. WA I can find it out. Like it's given. So MA is given and WA is given. Okay, how I have to calculate? What I'll do, I know that KF is given, delta TF is equal to KF dot M. Okay, so if it's KF dot M, KF is given 1.86. Molality is WB by MB. Its WB is 45 divided by MB. You can calculate. It is C2H6O2. Basically, it is nothing but 1, 2 carbon H, 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 H and OH. OH. So it is C2H6O2. So if you will calculate, it will be nothing but 12 into 2 plus 1 into 6 plus 16 into 2. So 24 plus 6, 30, and here it will be 32, 62 gram per mole. So 45 upon 62 into, yes, what you will do? 1000 divided by, they have given 600 gram. So this value you will calculate, you will get delta TF. Okay. So delta TF, what you will get? You will get 1.2 mole per kg. So you will get 1.2, sorry, it will be 2.2 Kelvin, because I was just giving you the value. You will get 2.2 Kelvin as a change. You can solve that, it's very simple. And if you got this 2.2 Kelvin, you can find it out the solution also, because for the water it's going to be 0 degrees Celsius, the freezing point. So you can find it out that delta TF is equal to TF naught minus, yes, TF naught minus TF. So I have to find it out. TF will be TF naught minus delta TF. So it will be nothing but 273.15 minus 2.2 Kelvin. You will get 270.95. So you can see that it has decreased. Before, water was freezing point was 0 degrees Celsius. Now it is less than that. So that's how you can relate and discuss the questions related to it. So what we have discussed today, guys, let me just quickly summarize it. We actually discussed about the two colligative properties. We understood what do you mean by colligative properties, and then discuss the two colligative properties. One is your relative lowering of vapor pressure, and next is your, yes, depression and freezing point. Both of them we have discussed clearly. What are the formulas, how we get it, what is the common statement for both of them, and we discussed a numerical also related to it. We'll be discussing some more numericals in the next class when we'll be completing the colligative properties. We'll be discussing 2 more in the next class. So make sure you're revising it. And I want to inform all of you guys, the way we are having classes on YouTube platform, we are also having a classes on Unacademy platform, which are special classes, and they are absolutely free. You can join that classes, that special classes, to get to know about even our plus course classes, and yes, to study the topics even in a more detailed manner. So you can do that. So if you have liked the session, you should like the video, and also if you have any doubt, you should put it on comment section, so that I will be answering it as soon as possible within 24 hours if you get any of the doubts. Okay, so you have to let me know that. Okay guys, so make sure you're revising this, and yeah, we'll be meeting in the next session then. Make sure you are pressing the bell icon, so that whenever you are getting any you can get notification about our classes whenever it is there on YouTube as well. So okay guys, we'll be meeting in the next session then. Thank you all of you. Bye bye. Thank you guys.